Hey, welcome. So, today let's talk about a piece of tech that's working behind the scenes, totally changing the game for manufacturing and robotics. It honestly sounds like something straight out of a sci fi movie, but it's very real and it's already here. And it all kicks off with one incredible, almost unbelievable prediction. Just let that sink in for a minute. Predicting a super complex mechanical failure 3 weeks in advance? That feels like it should be impossible, right? This isn't just guesswork or waiting for the next scheduled maintenance. This is about knowing.
So you have to be asking, how on earth are they pulling this off? What's the secret sauce? Well, the answer is this amazing concept that builds a perfect bridge between the physical world and the digital one. It's called a digital twin.
Now, hold on. This is way more than just a fancy 3D model or some basic computer simulation. A digital twin is a living, breathing virtual copy. It's constantly getting fed real-time data from the actual robot. It literally learns and evolves and ages right along with the machine out on the factory floor.
Okay, so to really get our heads around how this works, we've got to look under the hood at its core components. The whole system really stands on three essential pillars that make that bridge between the physical and the virtual actually possible.
So first up, you've got the physical entity. That's the actual robot doing its thing, with all its sensors and gears. Then you've got the virtual entity, its super detailed digital replica. But the real magic, the absolute key to the whole thing, is that third pillar, the constant two-way stream of data that connects them. That's what keeps the virtual twin perfectly in sync with reality.
All right, enough with the theory. That's how it's supposed to work. But what does this actually look like in the real world? Let's dive into how this tech is causing some serious revolutions on the factory floor as we speak.
Okay, the first huge application is predictive maintenance. You know, the old way was to service a robot on a fixed schedule, right? Like every 6 months, whether it needed it or not. With a digital twin, the robot basically tells you when it needs help, because its virtual copy starts showing tiny signs of wear and tear first. And the results? They're absolutely staggering. In one automotive plant, they used digital twins for their robotic paint sprayers and cut those costly out-of-the-blue production shutdowns by a whopping 67%. And this isn't just a fluke. Across the board, companies that really lean into this are seeing their total maintenance costs drop anywhere from 25 to 40%. I mean, that's a massive impact on the bottom line, and it all comes from working smarter. Next up is another total game changer, virtual commissioning. So imagine you have to set up a brand new production line. The old way involved building it, then spending weeks on the floor, physically testing and debugging every little thing. Instead, you build the entire thing in the digital world first. I mean, just look at the difference here. On the left, that's the old way, weeks of chaos, high risk of things going wrong. But on the right, with the digital twin, you can run millions of tests in a virtual space, iron out every single kink, and slash the real-world setup time by up to half. Companies like Siemens are already using this to get massive, complex systems running with practically zero issues from day one. And finally, there's the ongoing process of optimization. The digital twin becomes this perfect virtual sandbox. Engineers can play around with what-if scenarios all day long. What if we tweak the robot's path just a tiny bit? What if we speed up this one step? They can test thousands of ideas to find the absolute most efficient way to run things, leading to huge energy savings, getting more products out the door, and way better quality. Now, let's be real. Making this all happen isn't exactly a walk in the park. It's a pretty complex job, but understanding the hurdles is really the key to unlocking the incredible future that this technology promises. You know the saying, garbage in, garbage out? Well, a digital twin is only as smart as the data it gets, so sensor reliability is a massive challenge. Then there's the crazy amount of computing power needed, and trying to get this new tech to talk to older systems can be a real headache. But for every one of these problems, smart solutions are already coming into play. Things like backup sensors, hybrid cloud systems, and smarter ways to upgrade. So far, we've seen how these digital twins are amazing tools for watching and predicting things. But what happens when we give them the power to act on what they learn? This is where things get truly wild. This is what's coming next. We are moving toward a future where the digital twin doesn't just flag a problem. It learns, it runs experiments in its virtual world, and then it automatically makes improvements in the real one. It'll schedule its own maintenance, order its own parts, and optimize not just a single robot, but the entire factory ecosystem. So, really, the big takeaway here is this. The most advanced robots of the future won't be defined by their steel and circuits, but by the intelligence of their digital self. Getting this digital, physical connection right, that's what's going to decide who leads the next wave of automation.